we need to talk about is repetition. And specifically, we're going to talk about two flavors of repetition: counter-controlled loops and logically controlled loops. Now, repetition is a fancy way of saying that we have a group of statements executed 0 or more times. Okay, so first we're going to take a look at counter-controlled loops. Now I want to draw out a for loop for you and then ask you some questions about the for loop. These might be questions that you may not have asked yourself before or may not have been aware of. I had to become aware of this when I was teaching 103 to the freshmen, so I'm keenly aware of kind of the different parts of a counter-control loop so they can all make some logical sense. So here's my counter-control loop. For int I equals 0, I is less than 10, I plus plus, and then there's some code in here. All right. Now, there's a couple of different parts to this. So let's zoom in here and we can do a little counter-control loop anatomy. All right. So first of all, this has a special name. This is called the loop variable. That makes sense. Now, this is how we set the initial value of the loop variable. And there is typically some kind of mechanism to specify the terminal value here we're saying as long as I is less than 10. And then also, whoops, we also have the ability to specify a step size. Okay, so I have some questions now. So the step size right here is 1, but it could be 2, we could go up by 2, or we could go down by 1, or down by -2, or whatever. All right, so I have some questions now about this setup. All right, so here's my first question. Question number 1, can we change the scope? Oh, sorry, what is the scope of the loop variable? What is the scope of I? Well, as it turns out, that completely depends on the language that you're working with. So for some languages, the scope of I is it is the entire method that I exists within. From the moment that you define I, so from this moment forward, I is in scope until you exit the method. For other methods, the scope of I is actually from here to here within that block of code, so of which the for loop itself is considered part of that block. So when you exit the for loop, I doesn't exist anymore. Okay. So here's a question. What is the value of I right here? What is the value of I? Well, the, the answer again is it depends on the language's implementation of this counter-controlled loop. The value of I might be 11. This would be in a situation where I is defined at the beginning of this for loop, but it's considered to exist within the method and not within the block of code that is defined by for loop. So some languages do that. In other languages, I might be considered undefined. Because I is allowed only to exist for the duration of the for loop. And once you exit the for loop, I doesn't exist anymore. All right, so here's another question. Can we change I here? In here, in the body of the for loop, is it possible to change the value of I? I'm not talking about getting the value of I, but changing the value of I. For example, if I were to say like I equals 5 or something like that, or I equals I plus 10 or whatever, am I allowed to do that? And the answer to that is, again, it depends on the language that you're working with. So some languages like C and C++ will completely let you do that, but there's other languages that don't. Okay, so that's an example of a C-based counter control loop. Let's take a look at something that's a little bit different. Let's take a look at a for loop in Fortran. All right, so do 10 I equals 1, 30, 2. And I'm going to write I, 20, and I have a format statement here that is going to format I as a 4-byte integer. All right, and then 10 will be my continue statement. Oops, I'm going to move that over here. So continue. Okay, so let's talk a little bit about how this works. So this is the Fortran 77 version of a counter control loop, or should I say counting loop? Counter control loop, yeah. Counter control loop. Okay, so the way this works is there's a couple parts to it. So the first thing is we have an initial value, that's this. Then we have a terminal value, and then we have a step size. And the bounds of the loop is controlled by this continue statement. So this locates the line of code that should be executed once I has hit the terminal value. Right? So that's this. Okay. So here's my question then. Assuming that this loop runs, what would you expect to see as output for this loop, right? So we're doing a write statement, we're doing this format. What are we going to see as output for the loop? So take a moment to think about that. Okay, what we should see as output is we should see 1, because that's the initial value that I is set to. The next number after 1 should be 3, and that's because we're going to add our step size to 1 to get 3, then 5, then 9, all the way up to 29. Now, when we reach 29 and we output it with this format statement, we're going to hit this continue. We're going to go back up to the top to this do statement. We're going to use that stepwise incrementer to add 2 to I, and then we're now going to get 31. But our terminal value is 30, which is bigger than 31. So we're going to go to the continue statement, and we're then going to execute the next line of code right here. All right. Now, what would happen if, let's say, right here, right there, what would happen if I said I equals I plus, I think it's colon. Is it colon equals? Yeah. Let's say I were to do I equals I plus 10. Is it possible to do this? So the answer to that is, I don't think there's a colon. Okay, so the answer to that is this is considered a syntax error. So you cannot alter the counter variable in a counter-controlled loop in Fortran 77. That's illegal. What happens is that Fortran actually pre-computes the number of iterations that a loop is going to perform. And so my question is, given that that's the case, that it does this pre-computation, what is that? Can you figure out how to compute the number of times a counter-controlled loop in a Fortran program will execute, right? Given a particular terminal value and an initial value. Well, let's just say they're variables. So given an initial value, a terminal value, and a step size, what is the number of times that the counter-controlled loop will execute? All right, so take a second, hit pause, take a second to figure this out. Okay, so the answer is we're going to take the following, the terminal value, and subtract the initial value, and add the initial value and add the step size. And then we're going to take all that, add that up, and divide it by step size. And we're going to take the max of that and 0. Okay? So let's do an example. So let's say that, well, let's try the example up here. So the initial value is 1. We're starting at 1. The terminal value is 30. And the step size is 2. So 30 minus 1 is 29, plus 2 is 31. So we have 31 divided by the step size, which is 2. And 0. Pick the max of that. All right, so the max of that is, well, 31 divided by 2 is 15, so the max of 15 and 0. And that's going to give us 15. Okay. You know loops can't execute in fractions of an integer, so truncated version of that number 31 divided by 2. All right, so Fortran will pre-compute the iteration count at loop initialization. And after that, you can't change the count. You can look at its value, but you can't change it. All right, so let's take a look at one more Fortran example, and then you can answer how many times this loop executes. So do 10. I'm going to do this again. So do 10, k equals 10, comma 1, comma minus 2, and k equals k minus 1, and then 10, continue. Okay, so how many times will this loop execute? So hit pause, see if you can figure it out. Okay, so first of all, it's a trick question. That's not legal. You can't change the counter in a counter-controlled loop in Fortran. So you can't change its value. You can look at it, but you can't change it. So this is really k read only. All right. Secondly, how do we compute the number of times? Assuming we fix this, all right, so we'll just get rid of that, and we have some other code in here. How many times will this loop iterate? Well, we're going to take the 10, the terminal value, subtract the initial value, and add the increment. So that's going to be, and then we're going to divide by the step size, which is minus 2. Okay, so, well, all right, so that's 10 minus 7. Oh, oops, I screwed this up. Let's try this again. Follow my own instructions here. Okay, so we're going to take the terminal value, which is 1, and then we're going to subtract the initial value, which is 10, and we're going to add the step size, which is minus 2. So that is 1 minus 10 minus 2, and we're going to divide that by the step size, and it's the max of that. All right, so that is the max of minus 11 divided by minus 2, 0, which is going to give us 5, right? So we're going to have the loop execute 5 times. All right, cool. So let's take a look at how Ada does counter control loops. We looked at C-based, we've looked at Fortran, and now let's take a look at Ada. So for variable in reverse, discrete, range, loop, and then ending. All right, so discrete range is one of the following. It's either a subrange of an integer, for example, like 10 dot dot 1 or 1 dot dot 10, or it's an enumeration, for example, Monday to Friday, some kind of enumerated type. Okay, so let's take a look at an example, an actual piece of code. All right, so here is a variable count, which is of type float. and I'm initializing that to 1.35. Then sum, which is a type integer, and I'm initializing that to 0. And now I'm going to write a counter control loop. So for count in 1 dot dot 5 loop. Oops. 1 dot dot 5 loop. Sum, sum equals sum plus count. And loop. Okay. So, how does this work? Well, a couple of things happen here. So first of all, we have two different counts. We've got this count, and we've got this count. So the way Ada handles counters in a counter control loop is that the scope of the counter in the counter control loop is the loop itself. It goes out of scope once we're outside of the loop. So we can actually have two counts in this particular piece of code. We can have count, which is a float, and then once we get into the loop, we can have count, which is this local counter-controlled variable. Okay, so that's the first interesting piece of data. The second thing is, what is the value of the loop variable after termination? So what is the value of this count after termination of the loop? Well, it goes out of scope, so we don't have access to that counter control variable anymore once we exit the loop, so that's gone. What we would get if we queried what the value of count is 1.35. All right, the next question, can you change the value of the loop variable during iteration of the body? In other words, could I change count here, like count equals count plus 10? The answer is no, you cannot do that. That is something you can't do. Again, I think it's because Ada says, look, make up your mind here. Either I'm a counter-controlled loop, in which case the for loop itself controls the change in the counter, or I'm not. But you got to make up your mind.